Hello everyone. Welcome to Hydropower. Today we will be discussing about the mass and elevation volume curves. First we will talk about the mass elevation curve and then we will talk about the volume elevation curve. So before starting mass elevation curve and volume elevation curve, let's talk about its introduction. Mass elevation and elevation volume curves are important concepts in the context of hydropower projects, specifically when considering the design and operation of reservoirs. These curves help understand the relationship between the elevation of the water surface in the reservoir and the corresponding volume of water stored. They help researchers and scientists track changes in ice mass and volume over time, providing valuable information for studies related to sea level rise, water resource management, and environmental impact. Let's start with the mass elevation curve. Mass elevation curve, also known as storage elevation curve, shows the relationship between the elevation of the water surface in the reservoir and the total mass of water stored. It helps quantify the amount of potential energy available for hydropower generation as the water flows from higher elevations to lower elevations. The curve allows to calculate the change in potential energy as the water level varies. Now let's talk about the volume elevation curve. And volume elevation curve illustrates the relationship between the elevation of the water surface in the reservoir and the corresponding volume of water stored. It provides insights into how the reservoir's volume changes as the water level fluctuates. This curve is essential for determining the storage capacity of the reservoir, which impacts the availability of water for power generation and other uses. These curves are critical in hydropower projects. Now let's talk about the application of these curves in hydropower. Optimal power generation. Understanding the mass elevation curve helps optimize power generation by allowing to assess the potential energy available at different water levels. By knowing the total mass of water and the height it can fall, reservoir management. The elevation volume curve is essential for managing reservoir levels to balance water supply, flood control, and power generation. It helps operators decide when to release or store water based on electricity demand, water availability, and environmental considerations. Infrastructure design. These curves guide the design and sizing of reservoirs, dams, and turbines. They influence decisions about reservoir storage capacity, spillways, and other critical components. Efficiency analysis. By analyzing the changes in potential energy at different elevations, we can optimize the operation of turbines and generators for maximum efficiency. Environmental impact. Proper management of reservoir levels based on these curves can mitigate environmental impacts, such as downstream river ecosystems and aquatic habitats. The graphical representation of mass and elevation volume curves is as shown in the figure. Now, let's clarify it with an example. Here's the area elevation volume curve table for the hypothetical reservoir, starting from an elevation of 1,300 meters and including additional elevation points is shown in table herewith. You can have a look. Here we have considered a hypothetical reservoir, area elevation volume curve with an assumptions as reservoir shape, rectangular. Reservoir length, 100 meters. Reservoir width, 50 meters. Reference elevation, 1,300 meters. In this version of the example, the area elevation volume curve starts from an elevation of 1,300 meters and includes a range of elevation points to illustrate the linear relationship between elevation, area, and volume for the hypothetical rectangular reservoir. Here the graphical representation of the table shown above is as. Here, both the curves are increasing on increasing the depth of reservoir i.e. the elevation. Please keep in mind that this example assumes a simplified reservoir shape for illustration purposes. Real-world reservoirs can have more complex elevation-area volume relationships due to variations in shape, topography, and other factors. So, the viewers, this much for today. Thank you. See you in next video.